Have you ever wondered what life could be like beyond the confines of our blue and green planet? Our universe is a vast and intriguing place, a cosmos filled with endless wonders and mysteries. Imagine for a moment voyaging through the silent void among the stars, comets, and galaxies. It's a romantic notion, isn't it? The idea of exploring the great beyond, of being a spacefarer, is both exhilarating and daunting. Yet space is not just about the glimmering stars and nebulous galaxies. It's also about the stark realities and challenges it poses. The absence of gravity, the unending silence, the harsh radiation, each presents its own unique set of obstacles. A life in space is not just a dreamy journey among the stars, but also a test of human endurance, technology, and adaptability. Well, let's embark on a journey, comparing and contrasting life on Earth with life in outer space. Breathing. It's a simple act we take for granted on Earth, but in space it's a different story. Let's take a moment to appreciate the air around us. Earth's atmosphere, that thin blue line seen from space, is a life-sustaining blanket. It's composed mostly of nitrogen and oxygen, with traces of argon, carbon dioxide, and other gases. This unique cocktail doesn't just allow us to breathe, it also protects us from the harsh radiation of the sun and keeps our planet at a cozy, habitable temperature. Now, imagine stepping outside the comforting embrace of this atmosphere into the vacuum of space. Here, there's no air to breathe, no wind on your face, and no sky above. This is an environment of extremes: extreme cold, extreme heat, and extreme radiation. It's a realm that is fundamentally inhospitable to life as we know it. To survive in space, astronauts have to carry a piece of Earth with them. Their spacecraft and spacesuits are essentially portable atmospheres. These life support systems provide the necessary oxygen for breathing, remove the carbon dioxide that's exhaled, and maintain a safe temperature and pressure. It's like living inside a high-tech bubble that replicates the conditions of Earth. Yet, creating a mini-Earth is no easy feat. It requires a deep understanding of our planet's life-supporting features and a mastery of technology. The systems must be robust, reliable, and capable of operating in the unforgiving conditions of space. Even a minor failure can have dire consequences. This is why every breath an astronaut takes in space is a marvel of human achievement. It's a testament to our ability to understand and replicate the delicate balance of elements that make life possible. It's a reminder of how far we've come in our quest to explore the final frontier and how much we rely on the unique conditions of our home planet. So, while we inhale and exhale without a second thought on Earth in space, every breath is a testament to human ingenuity. Feel the weight of your body pressing down. That's gravity, a force virtually non-existent in space. In every moment of our lives, we are under the influence of a force that we often take for granted: gravity. It's the reason why we walk firmly on the ground, why an apple falls from a tree, and why our planet orbits the sun. But what happens when this force is stripped away? Imagine a world where you can't feel the weight of your own body, where you float instead of walk, where everyday tasks become extraordinary challenges. This is the reality of living in space. The absence of gravity, or microgravity as it is known, is one of the most significant differences between life on Earth and life in space. In microgravity, our bodies behave differently. Our muscles and bones, which are used to constantly fighting against gravity to keep us upright, begin to weaken and deteriorate. This is why astronauts exercise for about 2 hours each day in space to counteract these effects. Even the heart, which is used to pumping blood uphill against gravity, changes shape and function in space. It becomes more spherical and pumps less efficiently, which can lead to reduced physical capacity and changes in blood pressure. Our sense of balance and orientation also relies on gravity. Without it, astronauts often experience a disorienting sensation known as space adaptation syndrome, with symptoms similar to motion sickness. Despite these challenges, humans are adaptable creatures. Astronauts learn to navigate their weightless environment, to drink floating blobs of water, to sleep tethered to a wall so they don't float away. They learn to live in a world where the rules of gravity no longer apply. But even with all the training and preparation, the transition from gravity to microgravity is not an easy one. It's a stark reminder of how much we are products of our environment, how much we rely on the forces that have shaped our existence. In space, the simple act of walking is replaced by floating. reminding us of how much we rely on Earth's gravity. Imagine experiencing 16 sunrises and sunsets in a single day. Welcome to life in space. On Earth, our day is divided into 24 hours, a cycle of day and night governed by the rotation of our planet on its axis. This rotation, paired with the light from our sun, gives us a clear distinction between day and night, and it's something that our bodies have evolved to rely on. Our internal biological clock, or circadian rhythm, is directly influenced by these light and dark cycles. Now let's take a step off our planet and venture into the vast realm of space. If you're aboard the International Space Station, or ISS, a day is a completely different concept. The ISS orbits the Earth approximately every 90 minutes. This means astronauts on board witness a sunrise or sunset every 45 minutes, adding up to a staggering 16 each day. This rapid day-night cycle can play tricks on the human body's circadian rhythm. On Earth, our bodies naturally respond to the rising and setting sun, helping us to feel awake during the day and sleepy at night. But when you're exposed to 16 sunrises and sunsets within a 24-hour period, this rhythm can become disrupted, potentially leading to sleep disturbances and other health issues. Astronauts on board the ISS have to adapt to this unique day cycle. They typically follow a schedule based on coordinated universal time, a time standard that doesn't change with the location in space, and it's roughly equivalent to the time in Greenwich, London. This schedule helps them maintain a standard routine, despite the irregular sunrises and sunsets. In this way, the absence of a natural day-night cycle in space poses a significant challenge for humans. It's a stark reminder of how our bodies are finely tuned to Earth's rhythms, and how different life can be when we step beyond our planetary boundaries. Thus, in space, our earthly concept of a day is turned on its head. So, how does life in space stack up against life on Earth? During our journey, we've explored three main differences between our home planet and the vast cosmic wilderness of outer space: the atmosphere, gravity, and the day-night cycle. Starting with the atmosphere, Earth's protective blanket of gases shields us from harmful solar radiation, regulates our climate, and enables us to breathe. In contrast, space is a vacuum devoid of atmosphere. This lack of atmosphere presents a significant challenge for space travel and habitation, requiring advanced life support systems to replicate the conditions we take for granted on Earth. Next, we dove into the world of gravity. On Earth, gravity holds us down, keeps our atmosphere in place, and governs the motion of the planets. Space, however, is a realm of microgravity. This not only affects how astronauts move and interact with their environment, but it also has profound implications on the human body. Prolonged exposure to microgravity can lead to muscle atrophy and bone density loss, which are serious considerations for long-term space travel. And let's not forget the day-night cycle. Here on Earth, we are used to a rhythmic 24-hour cycle of light and darkness that governs our sleep patterns, metabolism, and behavior. In space, this cycle doesn't exist. Astronauts aboard the International Space Station experience sunrise and sunset approximately every 90 minutes, which can completely disrupt their biological clocks. These differences between Earth and space highlight the broader implications for long-term space travel and habitation. While technology can help us simulate Earth-like conditions to some extent, the challenges are immense. Indeed, while space offers a new frontier for exploration, it also reminds us of the unique conditions that make life on Earth possible. As we reach for the stars, we must also remember to appreciate and protect the only home we've ever known. It's clear that life in space is not a simple matter of packing up and leaving Earth. The differences between our home planet and the vast expanse of space are staggering, demanding resilience and innovation from those who dare to venture beyond our atmosphere. The challenges of space, from the lack of atmosphere to the peculiarities of gravity and the peculiar day-night cycle, have pushed us to new levels of ingenuity. But these challenges also serve to highlight the unique conditions that make life on Earth possible. They remind us of the delicate balance that allows us to thrive, a balance we often take for granted. So, as we aspire to become interstellar travelers, let's not forget to appreciate the marvel that is our home world. As we continue to reach for the stars, we're reminded of the beauty and fragility of our own planet. After all, there's no place like home.